If you're a software engineer wondering how to transition into AI engineering, here is the complete roadmap, layer by layer, from skills that you already have to building real production AI systems. And I know what you're probably thinking right now. Do I need to go back to school? Do I need to relearn calculus? Do I need to read 100 research papers before I can even get started? No, you really don't. Here is the thing that nobody tells you about becoming an AI engineer in 2026. You are not trying to become a researcher. You're just extending your skills that you already have into systems that happen to have probabilistic components. That's a very different problem than learning machine learning from scratch. The path from software engineer to AI engineer is way shorter than people make it sound if you know what actually matters and what's just noise. And that is exactly what I want to walk you through right now. So before we go any further, I'm Aishwarya Srinivasan and I've worked in the machine learning and AI for over 10 years now. I did my master's in data science from Columbia University, worked at companies like Microsoft, Google, IBM and Fireworks AI. So everything I'm sharing here comes from what actually works in practice. Before we talk about models or prompts or agents, I need to give you a reality check. And I'm saying this because I genuinely want you to succeed. If you are shaky on your software engineering fundamentals, fix that first. And when I say fundamentals, I don't mean lead code. I mean things like building and deploying APIs, handling ASIC code properly, working with Docker, understanding basic cloud infrastructure, writing tests, designing systems that don't fall over when something goes wrong. Here is why this matters so much. AI systems amplify bad engineering. If your foundations are wobbly, adding AI on top of that doesn't make it magically better. It makes everything way more fragile. Now you're dealing with distributed systems plus model latency plus token limits plus unpredictable outputs, retries, and costs that scale in ways that you cannot expect. I've seen this happen so many times. Someone builds an AI feature that looks amazing in demo, and then it completely collapses in production because the model API times out, or returns a malformed output, or costs explode overnight, or nobody thought about caching. So be honest with yourself. If you're not comfortable shipping and maintaining a reliable service today, pause here. Spend a month or two strengthening that. It'll make your AI journey faster because you won't be learning everything at once. But if you're solid on your software engineering fundamentals, if you can deploy a service, handle failures, and debug production issues, you're in a great position. So let's move on from here. The first real AI specific step is building a mental model of how large language models actually behave. And I want to be very clear about what I mean here, because this is where people get lost. I'm not talking about transformer math. I'm not talking about attention matrices and positional encoding. You don't need to understand that to be an effective AI engineer. What you do need is practical intuition. You need to understand what tokens are and why models think in tokens instead of words, why prompt length matters, and what happens when you hit context limits. You need to see why the same prompt sometimes gives you different answers. You need to understand how temperature affects the randomness of your answer, what models are consistently good at, and when they break. The biggest mistake I see is engineers starting with research papers. Papers are great for depth, but they're terrible for building intuition. Instead, here is what I want you to do. Pick a model provider, whether it's OpenAI, Anthropic, Gemini, DeepSeek, whatever. Go to the playground or a console where you can access the model. Run the exact same prompt 20 times. Change the temperature, watch how the outputs change, push the context window until it breaks. Track the token usage and latency as well. Go ahead and try ambiguous prompts and see how the model handles uncertainty. You need to try to make it fail on purpose. You're training your intuition and not memorizing definitions at this point. And this intuition is what saves you in production when something weird happens and you need to debug it quickly. Spend a few days just doing this, just experimenting. This is one of those things people rush through and then they pay for it later. Once you have that intuition, the next step is calling models from code. This is where your software engineering background again becomes your advantage. Here is the mental model I want you to adopt. Treat model APIs like unreliable external services because that's exactly what they are. They have rate limits, they have timeouts, they occasionally fail, sometimes they return output that doesn't match what you asked for. And sometimes latency spikes for reasons that you can't even control. If you've ever integrated integrated with a payments API or shipping provider, they should feel familiar. So what does this mean in practice? You add retries with exponential backoff. You set proper timeouts. You handle errors gracefully. You log inputs and outputs so you can debug them later. You think about fallbacks, like what happens if the primary model is not available. So here is your first concrete project that I want you to build. Build a simple API endpoint using Fast API or Flask that calls a model. It validates the input, returns structured responses, handles failures cleanly, and makes sure that your service does not crash just because the model call failed. At this stage, you're not just building fancy AI, you're learning to build model-powered services that don't fall apart. And that mindset is everything. For resources, the OpenAI Python SDK docs are solid. Anthropic SDK is also very clean. If you want to work with open source models, Fireworks is a great place to start. So now let's talk about prompting. And I'm going to be very honest here because this is one of the most misunderstood parts of AI engineering. Prompting is not magic. It's not copy-pasting viral prompts. It's not secret phrases. Prompting is an interface design. You're building an interface between your application and a probabilistic system. And that interface needs to be predictable, testable, and robust. Think about how you design APIs. You define inputs, you enforce schemas, you handle edge cases, and you document every expected behavior. And then finally you test it. Your prompts should work the same way. So use structured outputs. In Python, use Pydantic. In TypeScript, you can use Zod. Make the model return valid JSON every single time. Not most of the time, every single time. Explicitly define what the model should do when it is uncertain, or when input is invalid, or when the task cannot be completed. Here is a rule that I want you to internalize. If your prompt breaks when the input changes slightly, it is not production ready. If it only works for examples that you tested, it is fragile. And please store prompts like a code. Put them in files, version control them, write tests for them. You should be able to see exactly what changed when a prompt is modified and verify that nothing broke because of it. This is the difference between hobby projects and real systems. Next, we need to talk about RAG or Retrieval Augmented Generation. And this is a non-negotiable. Most real AI products today rely on RAG. It may not always be fine-tuning, may not always be agents, but it has RAG. You might ask why? Because models have knowledge cutoffs. They don't know about your internal data and they hallucinate because of it. RAG solves that by retrieving relevant information from your own data set and giving it to the model. The model doesn't need to know everything. It just needs to reason over the context that you've given it. So what do you need to learn here? First, it's chunking. How do you split the document matters more than people realize. Too large and you waste the context, too small and you're losing the meaning. Different data types need different strategies. Second is retrieval methods. You need to understand the difference between embedding-based search and keyword-based search, and when to use hybrid approaches. Embeddings are great for semantic similarity, but keyword search still matters for exact terms, IDs, and names. Then the third thing is latency, which is retrieval plus generation adds up fast. So if retrieval takes 2 seconds and generation takes 3 seconds, your user is essentially waiting for 5 seconds. That is bad user experience. So for tools, pick one embedding model and learn it well. Learn a vector database like Qdrant, Viviet, or Pinecone. Use LangChain or Llama Index if they help, but don't rely on them blindly. You should be able to explain why a specific chunk was retrieved. If you can't explain your system, you can't debug it. Your project here is very simple. Take a set of documents, chunk them, embed them, store them, and retrieve relevant context. Compare the outputs with and without retrieval. That comparison will teach you more than any other tutorial on how RAG systems work. Now we move into the tool calling and agents. This is where models start doing real work. Tool calling means that the model can call APIs, run functions, query databases, or trigger workflows. And this is also where things break most often. It is easy to build a demo where the model calls a tool once. It's hard to build a system where it does that reliably thousands of times every single day. You need to understand tool schemas, argument validation, failure handling, and guardrails. So here is a project that I would recommend for you to learn this. Build an agent that can call at least 2 tools. Validate everything before execution. Handle the failures gracefully and make it boring and reliable. Once that works, move with the multi-step workflows. Now this is what is agentic AI systems. Here you need to learn learn concepts like state machines, planning versus execution, memory management, and observability. Frameworks like LangChain, CrewAI, or AutoGen can help, but focus on patterns and not just tools. AI agents often fail silently. They confidently do the wrong thing. So if you don't build observability from day one, you won't know until users start complaining. And the final thing that you need to learn is evaluation, deployment, and cost control. This is where real engineers stand out. You need to build evaluation data sets, you need to run regression tests on prompts, you need to track the latency, cost, and error rates, and set up alerts. You need to optimize for the cost, so do cache aggressively. You do need to do batch requests and use smaller models whenever possible. If you can save a company 30% on inference costs without hurting quality, you become an extremely valuable AI engineer. Now, if you're thinking about fine-tuning, that comes very last. Only do it when you have a clear reason for it. Build one solid demo that shows measurable improvement, and your portfolio project should have at least 2 to 3 production-grade projects. Include the architecture diagrams, discuss the trade-offs, and talk about what broke and how you fixed it. That is engineering maturity. I know this was a lot, so let me wrap this up. First, start with the strong software fundamentals. Then, build intuition about these models through experimentation. Then, treat these models like unreliable services and design prompts as interfaces. Then get into RAG, then get into tool calling, and then invest in evaluation and observability. And then finally, you get into optimizing for the costs. AI engineering is not a career reset, especially for software engineers. It is software engineering plus models plus judgment. And all the resources that I've mentioned above are linked in the description below. So I would say bookmark them. And if this video helped, please do subscribe to my channel and click on the bell icon so you get notified every time I post. I regularly post about AI and ML careers, free resources, technical explainers, and my journey building a career in AI as an immigrant in the US. And please do drop a comment and tell me where you are at right now. And what do you want me to go deeper on next?